Hello everyone. In this video, we are going to work on section 8.2 and the other sections will be spoken in next videos. So first part is about section 8.2, which is about vectors. For the first question, it is asking about drawing a plus b, half of b, and 2b minus a. For the first one, if we want to draw it, okay, if you want to draw a plus b, you can use either triangle law or parallelogram law. So let's say we want to use triangle law. We would start from the first one, a, and this is b. So a plus b is here. If b is this one, half of b will be like this, 1 over 2 times b. And for the third one, if b is this much, we would double the length that these two arrows together, that would be 2b. And we also need to know what a is, and also we're going to use a. So let's say a is this one. We want to draw 2b minus a. You can use, okay, this one is a. So you can say that negative a is 2b negative a. It is the same as 2b plus the opposite of a. So if you want to draw the opposite of a, that would be this way. And 2b minus a or 2b plus negative a is like this. So this is 2b minus a. Question number 2 says if a is 2, negative 4, and 4, and b is 0, 2, negative 1, we are supposed to find a plus b. So it will be adding first component, which is 2 plus 0, negative 4 plus 2, and 4 plus minus 1, or negative 1, which will be 2, negative 2, and 3. For the next one, which is 2a times minus 3b, it will be 2 times a, which is 2, negative 4, and 4, minus 3 times 0, 2, negative 1. So the first one would be 4, negative 8, and 8. The next one, if you multiply that by 3, would be 0, 6, and negative 3. Altogether, if you subtract this, you would have 4. Negative 8 minus 6 is negative 14, and 8 minus negative 3 means 8 plus 3, which is 11. Question number 3 is here. Find a unit vector that has the same direction as the vector negative 4, 2, and 4. So if we call it A here, and in order to find u, which is the unit vector associated with A, is dividing vector A by the absolute value of that, or the length of that. So we know that A is negative 4, 2, and 4. But what is the length of A? That would be square root of negative 4 squared, 2 squared, and 4 squared, which will be square root of 36, which is 6. So we would divide all by 6. which is -4 divided by 6 and can be simplified to -2/3. Next one, 2 over 6 can be simplified to 1 over 3, and 4 over 6 is going to be 2 over 3. Question number 4. Okay, for this one, let's say this is the surface or the ground, and it will be thrown here, let's say V, and we know that this is perpendicular. So we can call it V component, vertical component, and this one horizontal component. And let's say this is alpha 40 degree. So how can we find horizontal component? In order to find horizontal component, we're going to use trig functions. Let's say we are going to find horizontal component. What is the position of this line, which is horizontal component, comparing to alpha? That would be adjacent. So adjacent is related to cosine. So if I want to find cosine of alpha, that would be horizontal component, this part here, divided by V, but we need to find the absolute value of V. So it will be horizontal component will be the absolute value of V times cosine of alpha. According to the question, the absolute value of V is 60 times cosine of 40. In order to find this, you can use calculator and you would find it as 60 times cosine of 40 degree, which is absolutely 45.96 feet per second. Same idea for vertical component. Let me write that here. So for vertical component, since vertical component is the opposite comparing to alpha, we would think of sine of alpha. If we want to find the sine of alpha, that would be vertical component divided by the absolute value of V. So from here, vertical component is the absolute value of V times sine of alpha. We know that absolute value of V is 60, and we're going to find sine of 40 degrees using the calculator, and that would be 38.57 feet per second. Okay, number 5. As we talked before, this is a vector that can be written as 1 because the coefficient here is 1, 2, and -3. Also, we can write b as 4. We don't have any j here. It means that the coefficient is 0 and 7. So we are going to evaluate 2a plus 3b. So 2a plus 3b, you can write it either in ijk form with basic vectors, or you can write it as bracket. It's up to you. Let's keep it this way. So 2 times I plus 2j minus 3k plus 3 times 4I plus 7k. And you would multiply them together. You would have 2I plus 4j minus 6k. And this one, if you multiply 3, you get 12I plus 21k. Altogether, you would have 14I plus 4j plus 15k. For the next one, which is 7a minus 5b, we would do the same. So 7 times I plus 2j minus 3k minus 5 times 4i plus 7k. And that would be 4i minus 20i. It means negative 13i. Next part will be 14j here, because we don't have any j's here. And the coefficient of k would be negative 21 minus 35. That would be negative 56k. Next one is 3a minus 2b. It means you would multiply 3 to I plus 2j minus 3k, and also negative 2 times 4i plus 7k. And in here, if we multiply 3 and negative 2, we would end up negative 5i plus 6j minus 23k. Number 6. Find the unit vectors that are parallel to the tangent line to the parabola y equals x squared at the point that is given to us. So we know that the slope of the tangent line to y equals x squared is y prime, which means 2x. And we have the point 2 and 4. It means that instead of x, we can put 2 and the slope will be 4. So this is the slope of the tangent line. In order to write the equation, in order to find the unit vectors that are parallel to the tangent line, we would say that when slope is 4, it means 4 over 1. We know that this means rise over run. But what this mean? It means that a parallel vector to the slope of 4, which can be 4 over 1, are two numbers. When you divide y value over x value, you get 4. So the simplest one is 1 and 4. But you can pick 2 and 8, also 3 and 12, because if you divide y value to x value, that would be 4. So let's pick the easiest one. If we pick this one as the vector, so the unit vector, which is related to v, would be 1 and 4 divided by the absolute value, which is 1 squared plus 4 squared. That would be 1 and 4 divided by square root of 17, which is 1 over square root of 17, and 4 over square root of 17. And number 7, suppose we have a vector 2, 3, negative 4 makes angles with the positive parts of x, y, and z axes respectively. Find the components and show that cosine squared of alpha, beta, and gamma, when they add up, you get 1. So as a reminder, cosine of alpha was the first component divided by the absolute value. Cosine of beta would be the second component divided by the absolute value, and cosine of gamma will be the third component over the absolute value. So for this vector here that is given to us, cosine of alpha would be 2 over the absolute value of u. Okay, let's say this is a. It will be 2 squared 3 squared, and negative 4 squared. That would be square root of 4 plus 9 plus 16, which would be 29 here. So you would divide it by square root of 29. For cosine of beta, that would be the second component, which is 3 over square root of 29. And for the next one, that would be negative 4 over square root of 29. Last part says, prove that these, if you find the square of them and you add them up, you get 1. Okay, let's say what is cosine squared of alpha? That would be 2 squared, which is 4, over square root of 29 squared, which is 29. The cosine square of beta would be 9 over 29, and cosine squared of gamma will be 16 over 29. Let's say we add them up. This one plus this one plus this one. So if you know that the denominator is 29. What if you add 4, 9, and 16? That would be 29, so the answer is 1. The solution of the next sections is going to be on the next video.